Welcome to Sustainable Design. In this course, we are going to talk about how to design a residence that meets sustainability criteria. One of the things we need to do is start at the beginning when we start our site analysis for our design, because sometimes we're involved in the selection of the property. The client doesn't always come with the lot already selected. Or if they do, then we still need to analyze it. And what that's going to allow us to do is make determinations about how we orient not only the building on the site, but also spaces within the building to best make use of the principles of sustainable design. And so what we want to start with in the very beginning is the site analysis, because that's going to help us make some decisions as we move through the program. When we develop the program and start doing our bubble diagramming, this information, the site analysis that we're going to do, will help us make decisions. Okay, so site analysis involves looking at and preparing site plans. And so let's talk about what is a site plan. There's an example of some contours, and you can see these numbers and these dashed lines. And I'm going to show you what those are and what those mean if you don't already know. The dashed ones are the existing land. You will hire, or the contractor will hire, if the contractor is working with you, or the client may have already hired a land surveyor to figure out what the actual physical terrain is of the property. And once that you have that, you're then able to make decisions. For the most part, this property gently slopes down. But if we leave this existing contour line and put our residence here, we're going to have a drainage problem because water is draining this way. And so while the dashed lines are existing contours, and I'll show you physically in a 3D model what that is. The solid line right here, and it should have a number associated with it over here too, just to confirm that we're making sure this stays at 10. I would have put a number over here, 104, so that 104 continues here now. So this area between the dash line and the solid line is currently sloping down, but we're going to grade it out. And so what will happen is this whole space between here and here will be the same elevation. I would have done a swale on each side just to make sure that the water does not, and I would have, sorry, I'm sort of evaluating other people's work, but it's good for you to see me do that. You know, I mean, I took an entire class on site planning in college, and I had to do these very detailed site plans. And I don't want to get too far ahead of myself because that's where I'm about to head, and I don't want to go there yet. And so here's the definition of what a site plan is. And it's essentially a drawing that we use to take what's existing and show how we want to modify it. And it shows buildings, roads, sidewalks, parking, drainage, water lines, any other utilities, landscaping, right? So it's basically included in our set of construction documents that the builder or contractor will use to make improvements to the property. And you can almost always get your plat through the county. The county is supposed to keep these. And if not, then you can go out and have a survey done. A land surveyor can go out and using special equipment. I spent a summer doing this. It's hard. It's fun, but it's tough to learn how to use the equipment. But they can go out and they can survey the property and they can get you a site plan or a contour map. And we'll talk about what that is in a minute. This is a conceptual site design. This is prepared for a client to show them the intended design. It is not a site plan because it does not provide enough information for the contractor or builder to properly grade the site or locate the buildings. It's missing quite a bit of information. However, it's pretty and it helps the client to understand the concept. And they did a really nice job with that. Done on the computer. Okay, so on our topographical map that we have, and that is what the lines I showed you is the topography, is the terrain. Those are the vertical and horizontal dimensions of a land surface. Okay, the terrain is the lay of the land, and it's usually expressed in terms of elevation. That's what these numbers are. These are elevation. And in this case, 0 corresponds in this cone or this mountain to the sea. That 0 is sea level. So there's a coordinate system, a GPS system that is used to map the entire world. And I think the whole world has now been mapped. There may be some areas that haven't been, but I think most of the world has now been mapped. North America has been mapped. And so the 0 is sea level. So in this case, this mountain would be right on the ocean. And if you want to see mountains on the ocean, there are a lot of those in South America. It's beautiful. So that almost never happens with a mountain. But for the sake of understanding and explaining this, understand that the 0 elevation is sea level. Okay, and so that is indicated by if we were to take this cone and slice it off at 0, we would be on the bottom of the cone and it would equal this contour. And on the mountain, the same thing. If we're just to trace around the outside of the mountain, basically, we would get this contour. Now, if we decided we're going to set our increments at 10 feet, and that is a decision that you make based on the property you have. If it slopes greatly, 10 feet might be too little. You might need to do larger contours, because otherwise you're going to have a whole lot of lines really close together and it may be too much information. It becomes something that as you start working on projects and seeing, you start to understand a little bit better by working with it. It becomes a decision that is made on a project as to where you want to set the contour levels and where you want to, how far apart you want them. In this case, we're just going to go with 10 feet. So what we would do is measure 10 feet up in the air, right, on the z-axis, and then we would take a chainsaw and we would cut the cone or the property, or in this case the mountain, at 10 feet and remove the top, and then look down and trace that outer line, that contour line of what's left. And that becomes this line right here, which projects down here, which is this circle. And then we go another 10 feet, and at this point we're now 20 feet above, and we cut again. And remove the top and look down, and that outline that we can see around which is the border of where we've cut, is now this outline. And so essentially what ends up happening is we end up with a plan view of outlines that represent the boundary of the shape or the form at that elevation. So these are the X and Y interpretations of the Z plane axis moving through the page. Another way to look at it is this. I have a piece of paper up here at the top, and I'm going to slowly move the cone through it. And I'm going to stop at elevation 50, and I'm going to capture that, and it's going to look like this. And then I'm going to move it up to 40, and it's going to look like this. So this is taking a three-dimensional object and moving it through a two-dimensional plane, and at those specific increments, marking the shape that comes through the paper. Okay, and so here's what it looks like this is a model. It's called a scale model that was built of the site, and it was done out of chipboard, and it's really thin cardboard. And you can see that for each contour there is a piece of chipboard, and that it corresponds to the contour. So what the person could do is you could take the plot plan that you have, the topographical map that you have, and lay it down on the chipboard and cut out around the boundary and have that first piece. And then you could cut the next one out and the next one out and the next one out, and then eventually stack these up. And so because this is actually Earth up here too, this is proposed because there's no way you can suspend that out. You'd have to cut this out. This is the side view. This is looking this way. It's like if you walked in here. Okay, so they cut this down the middle, split it apart, and pushed the sides apart, and then photographed them. And the photographs of the elevations of the sections are here and here. And so you can see, let's see, they have a person standing here. Yeah, you see that person there? That's that person there. And there's somebody back here, and that person's there. And so what you're seeing is splitting this, and you're looking inside. And now you can see these are those contour lines, all represented as a single piece of chipboard. And the thickness of this board, if you want this model to scale properly, needs to be the thickness of your contour. So this clearly, in this case, is about a foot. So these contours are a foot. So you see how close they are together, how many there are because they're only a foot apart. In this case, it was necessary to build a model that had a three-dimensional solid feel to it to get them close together. But most likely you would not have that many contours on your site plan itself. And this is just kind of showing you in 2D what I just showed you in 3D with, here's the original site. These are the contours. The numbers correspond to how high above sea level they are. And this is showing what they look like in elevation. And you can see, here's the 124, 125. They bolded the 5-foot increments. And you can see something called cut and fill. And that is showing you an example down here. The house was decided to be located here, so we had to modify the terrain to avoid water running into the house. Because you create all kinds of problems when your house floods. And so if you bring these lines cut through here, this is a cut line, you cut through here and you bring these lines down, they will correspond to where the terrain is on the map. And then the lines that are solid show areas of fill where they are, in this case, because this is going downhill, if they're to the right, this is a fill. If they're to the left, it's cut. Okay, so cut and fill refer to what we're doing with the dirt. When we're removing it, we're cutting it. When we're adding it, we're filling it. And the ideal, the goal, is to be able to cut and fill so that you don't have to bring in or export dirt because it's expensive. Or I should say soil. And then here's just a really beautiful three-dimensional cut through the site so you could see down here how this is cut into the land. Okay, I'm going to stop here and continue in the next video.